This third video of the Gauss-Jordan row reduction modified method as presented in your textbook is designed to show you how to clear out fractions that might be in your equation, which is the second step. And so we have this system of equations, negative 2/3 x plus y over 2 equals negative 3, and x over 4 minus y equals 11 over 4. Step number 1 does not change. It's simply transferring your equation into a matrix format. So we're going to have that first equation written then as negative 2/3 y over 2. If you ever see that, you are allowed to put a 1 as the coefficient in the numerator in front of the variable, which it's actually is a 1. We just multiply it in, and so 1 times anything is that thing, so that's why you only see the letter y. But when you need to know what was the actual coefficient of y, the numerator is a 1 and your denominator then would be a 2. And so you could see that coefficient really was a 1/2, so that you could transfer that into your matrix format. And then we have negative 3 as our total. In our second equation, we have x over 4. Similar idea as what happened in the first equation. You can put a 1 in front of that x. That allows you to see that your coefficient in front of x is really a 1/4. The coefficient in front of y is a negative 1, and our total is the 11 over 4. And this would be your first step. Just simply creating that matrix to move forward with. When you are doing step number 2, which we have not done in the other examples, it's a one row at a time type of manipulation. And what you're going to do is multiply a row by whatever it takes to get rid of the denominators that are creating the fractions. So we're going to look at row number 1 by itself, then come back and look at row number 2. So in row number 1, we have denominators of a 3 and a 2. So you need to think of a multiple between 3 and 2, so that if you multiply through by that number, it would allow the 3 and the 2 to cancel in evenly, making those denominators disappear. And so hopefully you're thinking of the number 6. 6 is a common multiple of both 3 and 2. So if we take 6 times every number in row number 1, that should cancel out those fractions. So if I take negative 2/3 times 6, that's going to give me a negative 4. If I take 1/2 times 6, will give me a positive 3. If I take negative 3 times 6, I'm going to get negative 18. It's very important that you also take this negative 3 times 6, even though it's not a fraction, it is part of that first row, and every number in that first row has to be manipulated the same way in order for your equation to still be the same in value. The second row has denominators of 4s in both of the fractions, so all you need to multiply through by is the smallest multiple of 4 that we have, which would be 4 itself. So we can take 4 times every number that's in row 2, and that should remove the fractions that are in the second row. So 1/4 times 4 would give you 1. Negative 1 times 4 makes it negative 4. 11 over 4 times 4 would be 11. And now we begin our row reduction process. From this point on, you are not allowed to do any kind of row operation that would bring in fractions or decimals until that very final step, which is why division is not allowed as a row operation in this modified method. So we're going to look at this negative 4. It's our first pivot number. We want to think of what we could do to make a pair of opposites here so that we could add and get a 0. We want to also make sure we remember that the row that the pivot number is located in is the row that does not change value, and so the pivot row should go ahead and transfer over into your next matrix as is, and then we write our row operation in front of the row that's changing. So we're going to write those row operations down here. So the negative 4 could stay a negative 4. If we could take 1 times 4, that would create a pair of opposites. So I'm not going to change the row 1 number. Let's keep negative 4 and negative 4, but I do want to take 4 times that row 2 number, and at that point I would have a negative 4 and I would have a positive 4, and so I'd want to perform addition to create a 0. So performing this math with each column, we would take negative 4 plus 4 times 1 is going to give us 0. Column number 2, row number 1 is 3 plus 4 times row number 2 would be 3 plus 4 times negative 4, and that's going to give you an answer of then negative 13. And then your final column, you would take the row 1 number, negative 18, plus 4 times the row 2 number, which is the 11. So negative 18 plus 4 times 11 should give you 26. I'm going to transfer this matrix over here just so we have a little more room to work. So I have negative 4, 3, negative 18 as row 1, 0, negative 13, and 26 is row number 2. We now move to our second row. Locate the first number that's not a 0. This becomes your new pivot number, which means that second row is now your pivot row. So transfer over 0, negative 13, and 26, because they're not going to change in value. And now your first row is what's going to change. So we're going to write those row operations up here at the top. You want to use that second column, the pivot row, the pivot numbers column, to be your strategy column. And if you're having a difficult time thinking of what can I multiply these two numbers by to get a pair of opposites, you could simply multiply them by each other. So you could take negative 13 times 3 and 3 times negative 13, or you could just multiply by 13 and 3 and then think through the signs and decide if you should be adding or subtracting. So if I just took 13 times that first number, that row 1 number, and 3 times the row 2 number, I would have a positive number, and down here I'd have a negative number, so I'd want to add in order to get a 0. So now I'm going to go first column, perform all of this arithmetic. So 13 times negative 4 plus 3 times 0 is going to give me negative 52. 13 times 3 plus 3 times negative 13, that should have been our 0. And then our final column, 13 times negative 18 plus 3 times 26 should give you a negative 156. Now that we have no other columns to move to, we are on the final step, which is to change our pivot numbers into a 1. So again, you want to relocate in your first row, your pivot number was the upper left-hand corner. Second row, the pivot number is located in the middle. And think through one row at a time what you would have to multiply by in order to make those turn into a positive 1. Any number of times it's reciprocal is going to give you positive 1. So if you have a negative 52, if you multiply by negative 1 over 52, that will give you a positive 1. But every number in that row must also be manipulated the same way. So that was going to change your row number 1 into negative 1 over 52 times negative 52 is 1. Negative 1 over 52 times 0 is 0. Negative 1 over 52 times 156, negative 156, is positive 3. The second row, pivot number was negative 13, so we would need to multiply by negative 1 over 13, everything in row 2. 0 times negative 1 over 13 is 0. Negative 13 times negative 1 over 13 is 1. And negative 1 over 13 times 26 is negative 2. Remembering that the first column was representing x's, second column was representing y's, the third column representing your totals, we have 1x is equal to 3, and we have 1y is equal to negative 2. So that tells us our point of intersection for this problem is 3, negative 2. And make sure you write that final answer as an ordered pair.